All right, good morning. So this is what we're working on, which is dilations. How do you describe properties of dilations? There's our key terms: similar, proportional, pre-image, and scale factor. Your shame. All right, so how do you describe properties of dilations? Well, you need to remember that dilation is a type of transformation, right? And it's not rigid, which means it changes the size and shape of something. So, we talked about this where at the movie theater, what you see projected behind you is like this little tiny square, but what's in front of you is a really big square, or really it's a rectangle to a much larger rectangle. That's called an enlargement. So when you take an original or a pre-image and you make it bigger, it's called an enlargement. But when you make it bigger, you can't just stretch it this way and leave it really, really short, right? Because then it doesn't look the same. So whenever you're enlarging it, or even if you're shrinking it, you have to do that so that all the sides are reduced or enlarged by the same amount. And that's known as scale factor. How you're changing the size has to be proportional, right? We're using a lot of math terms here, and this is good. So proportional means that each side, if I increase this side by 2, then I also have to increase the base by 2, meaning I'm making it twice as big and twice as big this way. I can't go, oh, this side's going to be twice as big and this is only just keeps it the same size, because now we don't even have the same shape anymore. So again, when it comes to dilations, the shape is the same, right? Like the overall shape, a square to a square, but one is either enlarged or reduced, okay? So our key term, similar. Similar means that you're looking at two shapes and the angles are going to be the exact same. The angle measures will be the exact same meaning equal, and the sides will be proportional. And what I was telling you before, proportional means that each set of the sides will reduce to the same ratio. So if I'm checking side lengths, they'll all reduce to the same number. They have to be the exact same. They have to reduce to the same number, otherwise it's not proportional. And if it's not proportional, then it's not similar. And if it's not similar, then it wouldn't be a dilation. Pre-image, like I said before, pre-image doesn't have that little accent mark there. It doesn't have it. And last but not least, scale factor. When I ask you for the scale factor, I'm asking you for the ratio of the sides. So it looks like part of the word got erased there. But I'm looking for the ratio of the sides. So the ratio of the side lengths, all right? So let's give an example of what I'm talking about here. And you can look at these on coordinate planes. They don't always have to be on coordinate planes. I know that what you did yesterday in 10-1 was on a coordinate plane. So you took like the coordinate of x and then the new coordinate of x and compared them along with comparing other coordinates as well. That's one way. I'm going to show you something here real quick though. Let's say I had triangle ABC, and I now have this little triangle. Okay, and the question is, are these similar? Are they a dilation, I guess? Is it a dilation? Well, to be a dilation means they have to be similar. So I have to check, is something being reduced or enlarged? So if I look at this here, I can see that my original seems clearly larger than the new one with the accent. So I would say this is probably a reduction, but I have to check. Are my angles congruent? Well, these little marks here tell me that they're congruent. Those are congruent marks for angles. So I can see it's telling me that angle A is congruent to A. and B is congruent to B, and C is congruent to C. I can see that because they have the same amount of little dash marks there. So now I have to check, are the side lengths going to reduce to the same scale factor? Are they proportional, right? So I'm going to list this, and I can see that side AB matches to AB over here. So I know that AB, I'm going to compare my new to my old. So I'm going to compare my original AB to my new. And that should be equivalent to, right, because proportional means all the sides should add up. So I'm comparing this side over this should be equivalent to this side to this, right? So this side I'm going to call B to C, B to C. And you know what? I even said new to old, and I did old to new. Whenever you're comparing them, it's always the new figure over the old figure. Big important thing there. I said it, and then I didn't do it, but I'm checking my work. So new with my accents to my old on the bottom. So my new C to A should match up to C to A. So CA over CA. Okay, now I'm just going to substitute in the information. What does substitute mean? That means I'm going to take the information that I have and place it into the proper descriptor. So what number matches to the AB? What is that side length AB? It is 5. And what is the original is 10. Should be equivalent to 3 over 6, which should be equivalent to 4 over 8. Okay, when I look at this, it's like, those numbers don't match. But again, remember, it has to reduce to the same ratio. So I have to make sure I know how to reduce fractions. Well, what can 5 over 10 reduce to, right? The lowest amount would be 1/2. What can 3 over 6 reduce to? 1/2. And what can 4 over 8 reduce to? 1/2. If they all reduce to the same ratio, which is a fraction, right? They all reduce to 1 over 2, then I can say, yep, this is in fact a dilation of a reduction. So it's a reduction. And the scale factor then I could say is 1 to 2, or I could write it as 1 over 2. Okay, and I could say, hey, this is a reduction. How come I know that? I know that because the angles are the same and the side lengths reduce to the same ratio. Okay? Again, why do I know it's a type of dilation? Is because they're similar. Similar means the angles are congruent and the side lengths reduce to the same amount, which they did. It's 1/2. So basically this is half the size of that. I know it's not drawn to scale. I know it doesn't look half to that, but I use numbers that would make it that way. So sometimes you're going to be asked, hey, is it an actual dilation and the side lengths don't reduce to the same amount? And this is how you check, and you say, no, it's not, because they don't all reduce to the same amount. Okay? All right, so let's look at another one. All right, so now what we're going to do is we're going to look at basically how to apply dilations algebraically. You were looking at what they looked like before, but now we're going to apply algebra to it, meaning now we're going to be solving for stuff, okay? So right here it says, what are the coordinates, or what would be the coordinates of ABC, the new image, if the pre-image ABC is dilated by a factor of 2. Okay, so here's my original, right? Here's my ABC. What would the coordinates be of a new one if it's dilated by 2? So what does dilated by 2 mean? Well, we know that how it's dilated is a type of scale factor, right? Like the last one was 1 over 2. So what would the scale factor be for this if it says by 2? What does that mean? What does every whole number go over? I know some of you know it, right? It goes over 1. So this is really what it's telling me. This dilated by 2 basically is telling me that they want it to have a scale factor of 2 over 1. Well, what does that mean? Remember, the top number represents the new image. The bottom number represents the original. So what it's telling me is it wants my new image to be twice as big as the original. Yeah, twice as big. So what does that mean? How do you make something twice as big? Well, you multiply it by dos, right? You're going to multiply by 2. Easy, right? Could I write a rule for that? Could I say that like my original xy is going to then become 2x and 2y? Would that be correct? Because I'm going to make it twice as big. Catching on? Good. So how are we going to do this? Well, first we have to list the original points. So my first point is my A. Looks like it is 0, 4. My B is, it looks like it's over 5 because this is 4, 6, 8. So that would have to be 5, comma 0. It didn't go up or down. And my C is 0, 0. Now I'm just going to apply this rule. So I'm going to multiply my x by 2. Well, what's 0 times 2? 0. What's 4 times 2 is 8. What's 5 times 2? It's 10. 0 times 2 is 0. And what is 0, 0 times 2? And 0 times 2 again would be 0, 0. Right? So here's my new coordinates. So now I literally can, let's make sure you can see that. All I did was multiply each one by 2 because it's a dilation of 2, so I made it bigger. If it was a dilation of 1/2, then I would be dividing it by 2. If it was a dilation of 4, I'd be multiplying by 4. If it was a dilation of 1/3, I'd be dividing by 3, right? So when they tell you to dilate by a fraction, that means division. If they tell you to dilate by a whole number, that means multiplication. Okay, so now I'm going to go ahead and graph my new one, and let's see if it looks roughly twice as big. So I'm going to go 2 zeros, 8, and I'm going to go out 8, 8. So 10 would be out here, and 0, 0. So my new one looks like that, twice as big. Do, 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 do. Okay. We'll work on this more, but I know that all of you are so good. I know you can catch on to it. It's just remembering those key terms. You know, scale factor is basically if I compare the sides, that they reduce that same amount. That also translates to how it's dilated. So if it has a scale factor of 1/2, then that means it was dilated by a half, which means it was made smaller or reduced. Okay? If it has a scale factor of 4, that means that it was enlarged 4 times. Because again, how they compare it is the new figure to the old figure. I'm comparing the new to the original. New image to pre-image. New image to pre-image. So important that you remember that piece. Proportional, again, keep using that term. That means that the ratio is the same. It's equivalent to all of them. 1/2 to 1/2 to 1/2. All right. Similar means that the angles are the same, sides are proportional. And a dilation is a type of transformation, so it's a type of change, but it is not rigid. So the shape does not remain congruent, but it either gets enlarged or reduced proportionately. All right? Good job. Get all your work done in Google Classroom, and I will see you mañana.